Alright, so we're going to do a quick demo of how to work with arrays in assembly. And so an array really is just a contiguous block of data. And there's no metadata attached like a dot length or anything. So it's a really low level. And there's two questions I want you to ask is how can I get, say, the third index of this array into R0? And another question is how can I get an ith index of this array into another register? And so the trick for both of these is we're going to be wanting to get the root address of the array. And the root address of the array is going to be the address of this first element. Alright. So what I'm going to do is I'm going to do something interesting. I'm going to give this first element a label. I'm going to do two commands. LEA 0. I'm going to try this command, LDR. And that's actually it. So what the hell just happened? Well, the first thing is this command gives me the root address of the array. And right now, if we start counting down, right? So this is x3000, and this is x3001. This halt command is located at x3002. This has break the code. This first element is x3003. Alright, so by running this command, what I did was I basically imagine this box is R0. I basically puts x3003 in this box. So I decided to load the effective addresses label. The effective addresses label is x3003. Now if I did a load command, alright, this would not be x3003. It wouldn't be the address to the left of it. It would be them. It would just be what's at the address. So it's going to fill my R0 with a 1 instead of 3003. So we want to do LEA to get that 3003, that root address into a register. And from there on, I can start using that root address in LDR commands. And I can just specify an offset. So we can walk through. As the LDR R1, R0, offset 3 command, you can read this as, I'll write it in text. This command is same thing as doing R1 equals mem R0 plus 3. That's how you can read this as human. So what is R0 plus 3? That's going to be 3006, right? If we add 3 to that. So what's at 3006? Well, let's see. It's like 3004. This is x3005. And this is x3006. And when you look at that, this happens to be the value at the third index of our array. That's how these two commands will work together. You can access arrays. Now, so just to summarize, the first step is to get the root address of the array into a register. You might need to use labels, and you might need to use an LEA command. And the second thing is you'd want to you treat that root address as your second parameter in your LDR command. Right? Now, what about if I want to get the ith index array? So let's say, and let's get rid of this, clean up a little bit. So let's just say we have a variable I, stuff with 2, like here. Now I can't just put an I right there, because offset only takes constant numbers. They don't take in variables. So we're gonna have to do a workaround here. So we're still gonna load the root address array in, but instead of doing that root address plus 3, all in one line, we're going to need to split it up into 2 different lines. What I'm going to do is I'm going to load R1 with I. And I'm going to do the adding in a separate line of code. So instead of doing it all in one with this offset trick, I'm going to keep this offset 0. And I'm going to be adding manually. So I'm going to be adding R0, R1, R0, R1. And then I'm going to load R1 into itself. So what the hell just happened again? No, first of all, these are outdated now. So what we did here was we loaded the root address array, which right now it's not even 3003 anymore if we count. I believe it starts at 3000, 2001, 3002, 3003, 2004, and 3005, 3006. Starts at 3006. And we loaded into R1 our I, which is R2. And then we added R1, and this command you can read this as R1 equals R0 plus R1. And that's going to turn this R1 into 3008. X 3008. And now what we did is I like to call it loading it into itself. So this command is going to be conceptualized as R1 equals mem of R1 plus 0. So I call it loading it into itself because really we're just saying R1 equals mem R1. And so what value is it 3008? Well, I trust that counted properly. 0, 1, 2, 4, 5, 6. Yes. Then this is X 3006. This is X 3007. This is X 3008. Notice that we're going to load in this 3. And this 3 happens to be our array of index I. So this is kind of like how you would do a variable index. You basically have to do the adding separately. And then just use a 0 offset all the time. So you have to get the root address and then get our index. And then add them together. Now in the homework, I think your arrays might look differently. So here our array's root address is close enough that we can use an LEA command. And this offset is up to 9 bits. So this is close enough that we can access it within 9 bits. All right. But let's say this array is at X 4000. That's way too far away for our. You might notice it's way too far away for our 9-bit offset. So what's going to happen is if we start using this, if I try to use LEA R0 array 0 command, I'm actually going to get an error that the offset's too big and it can't reach this label. So sometimes what you have to do is you have to be directly given this root address. Right now this root address of this 1 is going to be X 4000 because this dot origin is X 4000 and the dot fill is the first thing there. So this is a root address. So instead of using our LEA on a label, we have to just be explicitly given the root address. So it might look like something like this: array root address equals X 4000, or just X dot fill X 4000. And this might just look like array, really, I think. But you have to know it's root address. So now instead of having to do this LEA R0 array 0, what we're going to do is we're just going to directly load that root address in. Alright. And what this does is it's going to just straight up give us X 4000 into R0. So imagine R0 is here. And R1, we loaded it with 2. Because we loaded with I. And then we add R1, R0, R1. I guess let's make it general. Let's make this I. And this next command is going to turn this I instead to X 4000 plus I after this command. And then we're going to load it into itself. That's going to, this last command is going to make R1 equal to our array of I, just like that. This last command, it'll turn that X 4000 plus I to just straight up array of I. Alright, so hopefully this helps with homework 5, and thanks for watching.